So today we're going to work through the first part of a number guessing game in Python. The requirements for our game will be that first we're going to prompt the player for a maximum value, and we want to make sure that the player actually puts in a positive whole number. And so if not, we will continue to prompt them until the input is a valid input. This maximum value that the player has given is the range of values that we're going to select from for the number for them to guess. So if they give 100 as the maximum value, then the numbers will be from 1 to 100, including 1 and including 100. We're going to calculate the maximum number of guesses that are allowed, and in this case we want this maximum number to correspond to the number of guesses needed if they were to make the best guess at each point. Not necessarily the correct guess, but the guess that has the most impact on the number of guesses remaining, or the number of options remaining. We'll talk more about that in a few minutes. This goes until the player either guesses correctly or runs out of guesses. And at each guess, again, we want to make sure that the player is guessing a positive whole number. When a guess is made, we're going to tell the player whether the guess is too low or too high, unless, of course, it's the correct guess. But otherwise, we will tell them if it's too low or too high. At the end of the game, when they've either guessed the correct value or run out of guesses, then a pygame window will open. So in that window, if they've correctly guessed the value, then they get some kind of win screen, right? Congratulations, whatever, with some things moving around on the screen, some exciting things going on. If they run out of guesses, then they get a game over window, and then it will also show what the correct value was on the screen. On whichever type of window it is, whether it's the winning, whether the player won or whether the player lost, then we're going to have two buttons to prompt the player to either play again or quit. So just be able to click the button and then play again or quit. If play again, then that window closes and the game begins again. If it's quit, then another screen should come up, or another, whether it's a new window, probably not a new window, but in the same window, thanks for playing, goodbye, whatever, something like that. And then after 5 seconds, that window should close. As far as these tasks are concerned, some of these tasks we already know how to do based on previous lectures and previous labs, but a few of them we're not completely sure about, right? So at this point, we're going to talk through a few of the tasks and focusing on the ones that we don't yet know how to do all of the pieces. And when I say we don't yet know, in terms of what we've done in previous lectures and in previous labs, we haven't covered these topics yet. So for task 1, in terms of getting the input from the user for the initial range of values and later for the number for the guesses themselves, we need to complete 3 different tasks. We need to ensure that the player actually enters a value. And we have done this in previous labs in terms of checking to make sure that there is something that has been entered. And if the player just tries to press enter without entering a value, we force them to enter something. But then if they do enter something, we need to ensure that it represents an integer. And then if it is an integer, we still need to make sure that it's a positive integer. So we know how to check to see whether a number is positive, but the second bullet here, making sure that what they have entered actually is an integer, or at least can be turned into an integer, we haven't yet talked about how to do that. So to do this, we can use some built-in methods, and one of these is the string method isDigit. Now remember, when we use input in Python, that whatever we put in there, whether it looks like a number or not, is actually a string at the input stage. So if we said value, let's say that was our variable name, and we said input a number, that will be saved as a string. If we want to actually turn it into a number, we want to make sure that the user has entered something that can be turned into a number. And so isDigit is a built-in string method that will compare, it will check the value that was entered to see if it can be entered or can be turned into it says isDigit, but can it be turned into an integer value, a collection of digits possibly. So if we say enter a number and the person enters 1,4, well, 1,4 can be turned into a number. So the method, when we say value.isDigit, it will return true. If they entered a name or a pizza topping or anything else that can't be turned into an integer, even if they enter something like 1.4, that's not an integer, and so value.isDigit would be false in those cases. But if we get something that can be turned into a digit, or an integer, a set of digits, then we could go ahead and convert value to its integer value. So value then would become int value, and value then would no longer be a string, it would be an integer at that point. This may not be exactly the way we use this function or this method in the program, but this is the idea of how it works. If we try to convert something to an integer that can't be converted to an integer, then Python will give us an error message and our program will break. And so this allows us to check ahead of time without breaking anything. Can I turn it into a digit or into an integer? And if so, then I'll go ahead and do it. If I can't, then I'll have something else as another option that will be able to deal with that situation without breaking the program. Another helpful function that we may or may not need at this particular point, but it's related, and this function is instance. And so, for instance, if we gave a variable comma int as the parameters, again, isInstance is a Boolean. It returns either true or false. So if I had some variable name, let's say value, if we had value up here, if we looked at after we did the input, if we did isInstance variable or value comma int, at that point that would be false because value was a string at that point. But if we, after converting to an int, if we did isInstance value comma int, then we would get true as the returned value from the function at that point. So isInstance says, let's look at this variable, whatever its name is. That's what we put into the as the first parameter. The second parameter is the data type that we care about. And in this case, we're talking about an int. And when we put that in there, we either get true or false. Now, if we want something else other than an int, we can put that in place of an int. So if we wanted to check to see whether something was a string or a float or some other data type, then we can use that as the second parameter of isInstance. Task 2 we know how to do, so let's go on to task 3. And we had mentioned during the previous discussion about this that if we guess halfway between the low and the high values that are available, we will be able to successfully eliminate half of the remaining options. So we're going to be told too low or too high, and if we guess right in the middle, then we can throw away half of those values. And throwing away half of the values at each step is kind of the best case we can hope for. Overall, it kind of balances best case and worst case. If we guess too close to one of the ends, then we might get really lucky and throw away, say, 90% of the options. But if we're unlucky, we might only throw away 10% and be left with the other 90% still to be considered. So guessing right in the middle kind of balances best case and worst case, that we won't ever be stuck with too much. Right? So this really is kind of playing it safe by guessing halfway. You're never going to be left with too much of the remaining options without knowing. You will know which direction to go from there. And so what we need to do is calculate the number of guesses that we need in order to reduce that number of possibilities down to 1, right? So we have some number of things, throw away half of them, throw away half of the ones that are left, keep doing that until we're down to just one option. And that one option then would be the correct number, the random value that the system has chosen for us. And so to calculate the number of guesses needed, we're going to need to use logarithms. And so if we remember from a maths class somewhere that if we have a number a that's greater than 1, then log base a of x equals y means that a to the y power is equal to x. So the function log base a of x, we're looking for the exponent that gives you that x value. So, for example, log base 10 of 100. We're looking for the number that if you raise 10 to that power, that you get 100. So 10 to what power is 100? And that is 10 to the second power is 100. 10 squared, 10 times 10 is 100. If we change the base to a different number, 3 let's say, then we're looking at log base 3 of 27 in this example. What power do we have to raise 3 to in order to get 27? And in that case, 3 to the third power is 27. If we go back to base if we go to base 2 now, we have log base 2 of 32. So what power do we have to raise 2 to in order to get 32? And in that case, that is 5. So these are numbers that we recognize and possibly can figure out the logarithm fairly easily. What if we had log base 2 of 100? Well, log base 2 of 100, we look at this and try to figure out what that value is. And we know that this value is between 6 and 7, since 2 to the 6th is too small, that's only 64, and 2 to the 7th is too big, that's 128. So the exponent that we're looking for is somewhere between 6 and 7. And we look at 100, 100 is a little bit closer to 128 than it is to 64. And so we expect that log base 2 of 100 is going to be closer to 7 than it is to 6. And it turns out, if we calculate this, that it's about 6.6 something, and we can go to a lot of decimal places and never get there exactly, but we can get as close to 100 as we want to in terms of 2 to that power, getting closer and closer to 100. And so the number did turn out to be a little bit closer to 7 than it is to 6, because, again, 100 is closer to 2 to the 7th than it is to 2 to the 6th power. So how does this help us? Well, on one hand, we have the Python math module that we can import, and that will allow us to calculate logarithms easily. The log function in the math module, you give it a number that you want the logarithm of and the base that you want, and it will calculate this for us. So for instance, if we imported math and then did math.log 100 comma 2, we would get that 6.6 whatever value that we just saw. But what we care about isn't the logarithm. We care about the number of steps that we need to get to 1. But the number of steps that we need to get to 1 involves cutting things in half. So going the other direction would mean doubling things, which is where the power of 2 or the base of 2 comes into play. And so what we want in terms of calculating the number of guesses, we need that to involve the logarithm of whatever the max value was, but to base 2. And so when we do this, the number of guesses is an actual number of guesses, so that has to be a positive integer. But for instance, in the case of 100, log base 2 of 100 was not a positive integer. It was 6.6 something. And so for 100, what do we need? We can't have 6.6 guesses. But 6 guesses aren't always going to be enough. We need 6.6 something. And so what can we do with this value? We need to round it up. And taking a float value and rounding it up is called the ceiling. And so what we're looking for in this case is math dot, and the function in the math module is CEIL, standing, of course, for ceiling. So math dot ceiling, but again, just the CEIL. And then we put the number that we want in place. So if we were to do this with that 6.6 whatever value, math.ceiling, would give us 7 as the number of guesses. Now we can do this in a combined way, kind of do all of this at once. So we could set the maximum number of guesses to be the log of the max value to the base 2, and then the ceiling of that. So round that number up. Whatever number you get, round it up. Now, if the number turns out already to be an integer, then the ceiling is just that same number back. It doesn't go to the next integer. So if we did, say, max value of 32, so the log of 32 to the base 2 is 5. When we round that up, we still just get 5. That doesn't change the value at that point. But if we had gotten something like 5.001, that would get rounded up to 6. And we did see that sometimes the way certain numbers are represented in Python or in any kind of programming language, or in any kind of system, the digital system, that we can sometimes end up with an answer that's not exactly the answer that we thought we were going to get. Now, integers don't work that way, but the logarithm is actually returning a float value. And so if for some reason that float value can't be stored exactly, then it might be a little bigger or a little smaller than it should be, and so the ceiling could create, it potentially could create a problem in terms of going to a bigger number than we were expecting. Or if it couldn't display that number, then it might round to a smaller number than we were expecting. But as far as the mathematical aspect, it's always going to round to the correct value. And since we're talking about maximum value being an integer and we're talking about base 2, we won't expect any problems with calculating the correct number of guesses at this point. Task 4 we've talked about, we know how to do. So task 5, if we look at task 5 is another task that looks very much like task 1, except instead of getting an input to be the maximum value, now we're getting input to be guesses. And so since we're repeating pretty much the same idea, it might be a good idea to use a function to handle both of those tasks. In that case, the one function is doing the same thing. Otherwise, we would have to have some repeated code in the program, which sometimes we have done or we have seen that certain things we will repeat. But we do know that repeating code can create an issue in the sense of, if you find an error somewhere, then you have to find all the places that you copied that code and fix the error in all those places. And if you miss it in one place, or if you mess it up in one place, and then things don't work the way we want to. And so anytime we've repeated code, then we can see that that is at least a good possibility for using a function. And that way, that procedure is all taken care of in one place. And if there turns out to be a mistake in there, we can edit it in one place and it will fix it in all the places that use that, because it's always going back to that function for its for the calculations or for the steps that are needed. Step 6 we know how to do. Step 7, the pygame aspects, we have talked quite a bit about pygame and what to do. We haven't incorporated it in this way, and we haven't done any kind of writing to the screen or using buttons or creating buttons or something that will at least act like a button. And so the pygame part of the lab we will explore in the next lecture and be able to get the pygame aspect working the way we want to at that point. So as always, feel free to ask questions by email, on Discord, or in the comments. And keep working, keep trying these things, and have fun.